Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video, I am going to present some MCQs on the topic of simple trusses or simple frames of the subject theory of structure for the student of 4th semester of civil engineering diploma. Now without wasting the time, let us start. Question number 1. The forces in the members of a truss are determined using A. Method of sections, B. Method of joints, C. Graphical method, D. All the above. Now, for analyzing a simple frame or a simple truss, all these three methods are useful. They are of different types, each has got their own importance. Okay, so here we can use all the three methods, hence the correct answer is D, all the above. Question number 2. If the number of members in a truss are M, the number of joints are J, then the truss is said to be perfect if A. M is equal to 2J minus 3, B. M is greater than 2J minus 3, C. M is less than 2J minus 3, and D. None of the above. The frame is said to be perfect, okay, when its number of members are equal to 2J minus 3. Hence the correct answer is A, 2J minus 3. Question number 3. With usual notations of truss, if M is less than 2J minus 3, the truss is said to be A. redundant, B. perfect, C. deficient, and D. none of the above. Now, if number of members in a truss are less than 2J minus 3, then that particular frame is known as insufficient or deficient. Hence, the correct answer is C, deficient. Question number 4. With usual notations for a truss, if M is greater than 2J minus 3, the truss is said to be A. perfect, B. redundant, C. deficient, and D. none of the above. Now we saw when M is equal to 2J minus 3, it is perfect. When M is less than 2J minus 3, it is deficient. Now when it is M is greater than 2J minus 3, one member or two members can be, as the case may be, extra. Hence, they are known as, the frame is known as redundant frame. Hence, the correct answer is B, redundant. Question number 5. The most suitable analytical method of determining the forces in all the members of a truss is A. method of sections, B. method of joint, C. graphical method, and D. none of the above. Now, if you want to find out the force in each member of a truss, you will have to start each joint separately by drawing free body diagram and starting from a joint where there are not more than two unknowns, and then one by one you can solve the joint. Hence, the method of joint is the correct answer. Here, B, method of joint. Question number 6. Every joint in a simple truss is a point in equilibrium under the action of A. co-planar non-concurrent forces, B. non-coplanar concurrent forces, C. non-coplanar non-concurrent forces, and D. coplanar concurrent forces. Now, if you draw the free body diagram of a joint showing all the members meeting at a joint, all those members or all the forces are meeting at a joint, so they are concurrent forces. Hence, the correct answer is D, coplanar concurrent forces, because it is a plane truss, so all the forces are in one plane, so they are coplanar concurrent forces. Question number 7. While using the method of joints, one has to start from a joint where there are not more than dash 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 unknown unknowns. A3, B1, C2, D none of the above. In the 2-3 questions back I have explained you in method of joint you have to consider the joint one by one. You have to draw the free body diagram of a joint, but you have to start from a joint where there are not more than two unknowns, because that joint is in equilibrium under the action of coplanar concurrent forces. For concurrent forces, only two equations of equilibrium are available, that is summation of horizontal components equal to 0 and summation of vertical components equal to 0. So there should not be more than two unknown, hence the correct answer is C2. Question number 8. At joint C of a truss, three members CA, CB and CD are meeting. If CA and CB are collinear, then the force in member CD is A equal to force in CA, B 0, equal to force in CB and D none of the above. Now here it is necessary to draw the figure, simple figure. Three members are meeting CA, CB and CD. Out of that, CA and CB are collinear and CD is another member. What is the force in CD? So if two members are collinear and third member is also there, then whatever will be the force in that third member, there is no other member to balance that force, hence the force in that member is always 0. So if two are collinear, the force in third member is 0, hence the correct answer is B 0. Question number 9. At joint C of a truss, three members CA, CB and CD are meeting. If CA and CB are collinear and CD is perpendicular to them, then the force in CA and CB are. Now, again here three members are meeting. The options are A equal, B 0, C unequal and D any other value. Three members are meeting, out of which two are collinear and third is perpendicular. So there is no force to balance that third force. So it is 0, we know that. Okay. Hence the forces in those two collinear members are equal. Hence the correct answer is A equal. Question number 10. Two members are meeting at a joint of a truss. If they are mutually perpendicular, then the force in those members are A equal, B 0, C unequal and D any other value. Now only two members are at a joint and those two members are perpendicular to each other. So those are such that nobody can balance the other. Hence vertical force cannot balance horizontal force cannot balance vertical force. Hence the forces in both those members will be 0. Hence the correct answer is B 0. Question number 11. The most suitable method of determining the forces in specific members of a truss is A. Method of sections, B. Method of joints, C. Graphical method, D. None of the above. Now if you want to find out the forces in only few members of a truss, then it is always useful to prefer method of sections. Hence the correct answer is A. Method of sections. Question number 12. In method of sections, either side of the section is in equilibrium under the action of A. Coplanar non-concurrent forces, B. Non-coplanar concurrent forces, C. Non-coplanar non-concurrent forces and D. Coplanar concurrent forces. Now look here, whenever you take a particular section, either side of the section will be under the action of, they will not be concurrent forces, they will be non-concurrent forces. But as the frame is a simple frame, they are lying in the same plane. Hence, the correct answer is coplanar non-concurrent forces, that is A. Coplanar non-concurrent forces. Question number 13. While using method of sections, one has to take the section passing through the members having not more than dash 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 unknowns. A3, B1, C2 and D none of the above. Now whenever you are taking a section, the either side of the section is in equilibrium under the action of coplanar non-concurrent forces. And for non-concurrent forces, we have got three analytical conditions of equilibrium, that is sigma fx equal to 0, sigma fy is equal to 0 and sigma m is equal to 0. As three equations are available, we can find three unknowns. Hence the section should be chosen such that there are not more than three unknowns. Hence the correct answer is A3. So with this, I have prepared the MCQs for almost all topics of theory of structure for 4th semester civil engineering diploma students. So please go through all these MCQ videos, and whatever difficulties you are having, you can write the difficulties in comment box. Please share it to your friends. Please give the likes and subscribe, hitting the bell icon for all. Okay, so thank you.